hear me? Hello and welcome to today's weather briefing, which is held, as Markl has already said, by my colleague Andreas Wirth and me, Yasmin Markl. We are both working for the Austrian National Weather Service, ZAMG. Andreas is in Vienna at the remote sensing department of ZAMG, and I am in Salzburg working with satellite meteorology, but also with environmental meteorology and in forecasting. In the following half an hour, I will start with an overview about the current weather situation over Europe. Then Andreas will talk about heat waves, and finally I will give a short outlook about the weather in the next days. Okay, let's get started. I hope this works. I'm trying to get the next slide. Okay, so here we have the water vapor image of the channel 6.2 from today in the morning at 8 UTC. In our weather briefings, it is very popular that everybody shows where he or she comes from, so please just use one of the markers or a pencil, a digital one, of course, to show where you're sitting right now. And I will do the same to show you I am here in Salzburg. Yes, so we have Italy, Portugal, Great Britain, yes, the Baltic states, Finland even, right, Poland. Yes, very nice. Thanks a lot. So we can go on and then try once again. Okay, so before we have seen the water vapor image alone. This channel has an absorption band at about 350 hectopascal. Therefore, this channel receives the radiation only from the highest levels. And what we see here, the structures are represented for the very high layers, and therefore are really good for detecting dynamical structures, cyclogenesis, PV anomalies, jet streams, and that stuff, such as the darker stripes or areas show the dry atmospheric air that is brought downwards in the lower levels. I have also additionally added the geopotential at 300 hectopascal, also from 8 UTC, and this emphasize a little bit the dynamical structures that are going on. So we have obviously this very well-pronounced low pressure system over France that is today and the next days influencing the weather over Middle Europe and most parts of Europe, let's say. Yes, we can also see a westerly stream over here, and this is the low pressure system I was talking about. We have quite rather high pressure over here and high pressure areas over here. If we move on, I have additionally added the winds, the isotex, also at 300 hectopascal. And this again shows where dynamic processes in upper atmospheres take place. High wind speeds, for example, are detected here around this low pressure system, and as I said, here up in the northern Atlantic Sea. Yes, so that's about this. And now I want to show you the model chart of the ECMWF geopotential heights. These are the black lines and the temperature at 500 hectopascal, the color fields. What we can see here, as we have already seen, is this low pressure system over France and some temperature fields. So on the next slide, I will go one step farther. But before that, I also want to show you two small things. Very tiny troughs, very tiny disturbances. For example, here, I hope you can see the marker here over Austria, where we have this shortwave trough, and a second one over here over Poland, I guess, the Baltic states. There's another small disturbance, and I will come back to that a little bit later. So the next slide now shows the equivalent potential temperature at 850 hectopascal plus the tube potential at 300 hectopascal. And yeah, so what we can see here very clearly are some borders between different air masses. I know it's quite difficult for just one time step, but can anyone maybe detect a possible cold front? You can again take one of the markers or something and try to figure out where you would suppose, just from this image, where there could be a cold front. Any ideas? Yes, we have already some guesses. Yes, very good. Could you think of another one, maybe? Yes. Very nice. Okay, very nice. Okay, great. All right. I will now delete the markers. So yes, this is quite right. I think you have seen the most distinct ones. Clear annotations and clear pointers. Okay, thanks a lot. There's right now very heavy thunder going on outside. I'm a little bit distracted. I have seen in the chat box that some of you have really hot and sunny weather. That's nice, but here in Salzburg, it's right now there's quite a thunderstorm moving crossing Salzburg. Okay, let's move on here. I want to let you guess something else. Do you have any idea, or where would you expect that high-reaching clouds could develop on this map? Do you have any idea where the clouds are especially high? And I give you one hint. Maybe you want to think about the shortwave troughs that I have shown you before, that I have mentioned before. You don't see it on this map, I think, but on the map before, I have shown you the shortwave troughs. Yes. Okay. Yeah. Not too bad. Yes. Exactly. So now comes kind of the solution, I would say. If we move on, one second. If we move on to the ERMAS RGB, we can see that here over Eastern Austria in the morning, there was some high-reaching dense cloud signal, and also here over the Baltic states. What you can see in the ERMAS RGB as very white, bright color are high-reaching dense clouds, and this is exactly what's happening here. And also, as you have detected on the image before, here we have this rather high clouds from the frontal system. Let me just erase. Okay, so why do we see this especially here? I guess this has to do with the shortwave troughs that are exactly in these areas, because additionally to the heat and the moisture that is in the air, the shortwave troughs bring some instability, and therefore there's some convection that's going on, the same as right at this moment in Salzburg. Okay. And what else do we see on the ERMAS RGB? So we have seen high-reaching clouds. There are the two frontal systems, the one over Middle Europe and then another one here over the Northern Atlantic. We have also something else quite interesting. the red areas. So we have some very distinct red areas also here over the northern Atlantic, then here right in this low pressure system, and here, for example, over Turkey and eastern parts of this image. The red areas are dry air that is subsiding, and hence is a very good indicator of PV anomalies or cyclogenesis, and this is also why we see it right here or here, and here it's just very dry air. We also have some very blue areas. For example, in this area, blue areas represent cold polar air masses with a high moisture content in the upper levels, and then and then we also have some very green areas. For example, over here on the coast of Portugal and Spain, this represents areas of very warm air. Okay. All right. In terms of the weather situation, I will go back once. This brings again a very high risk of thunderstorms, because we have this rapid change of air masses over Middle Europe, and this brings unstable and humid conditions. And it looks like even more heat over Eastern Europe, especially over the southeast over here. And we have already had some heat waves. Andreas is going to talk about that soon. So the next slide shows the European warning platform Meteor Alarm that warns mainly heat and thunderstorms also for today. You can see it here. You can also visit the website meteoralarm.eu. So let's move on. I have picked out 3 webcam pictures from today in the morning. So we have Bremerhaven in very northern Germany, still sunny with some scattered clouds in the morning. Probably getting more cloudy in the course of the day, with also some clouds from this huge cold frontal system over Europe. Then we have Salzburg in Austria, already cloudy since the morning. Now thunderstorms, as I have mentioned, and rain. Probably not getting better until tomorrow. And Lisbon in Portugal has lots of sunshine, probably until the rest of the day. Yes, and then one last small thing, because we are talking about nice images of today. Andreas, just about 1 hour ago, has discovered these very nice structures over Madeira. Vortex Street, you can see in the high resolution visible satellite image, and over here you have this vortex street in the clouds that is called a Kalman vortex. All right, so now I will pass the microphone over to Andreas. And in the end, I will show a few more slides concerning the weather situation in the upcoming days.
So thank you, Yasmin. Hello, everybody. Have a nice afternoon. I will show you a few slides about heat waves. And because it's summer and the temperatures are quite high, so I have put together some considerations on summer weather, and especially on heat waves, present, past, and future. And when preparing this weather briefing, early this week, I came across an interesting article. Maybe you have also seen it or heard about it. It was published in the Lancet, in the Planetary Health magazine or journal, and there were a big echo in other media, on radio, on TV, and also in other papers like The Guardian and weekly Austrian paper called Profil. They were discussing and summarizing the outcome of this article. So what is this article about? It is quite interesting because it makes mathematically based prognosis of the fatalities and of the related to climate change in this century, so up to 2100, to the year 2100. And this article says that climate change is one of the biggest threats in this century, and especially towards the end of the century. And it discerns different causes of climate threats and natural disasters like storms, heat waves, cold waves, inundations or floodings, coastal floodings, river floodings. And it came out with this calculation this team made that the heat waves will cause towards the end of the century about 99% of all fatalities due to natural or weather hazards. They also divided this the study in different regions, and as you can imagine, not every European region is hit with the same intensity by the natural disasters. And they say that Central, Southern Europe and Southern Europe countries are most affected by human losses due to heat waves. And they calculated, this can be discussed if this way to calculate is exact or not, but they say in the Southern European countries there will be about 700 fatalities per 1 million inhabitants per year, which is quite a high number, and which is dramatically increased compared by now by about 50 times. And this study assumes that the emission of CO2 and other climate gases will not change in the future. In this study, you can easily Google it, and it's available without cost. They published this table, and here you see the fatalities per 10 million inhabitants, and on the y-axis, oh, I think I'm on the wrong page now, so I'm back, okay. So I just mentioned that on the y-axis you see the different reasons of the climate change, the different hazards, like heat waves, cold waves, and so on. And on the x-axis, in the horizontal, you see the time period. And sorry, you see the time period, and you see also the different regions of Europe. And what is very interesting is if you compare the increase of the heat waves here, the increase of fatalities in the heat waves, there will be a dramatic increase compared to the period of 81 to 2010, from 100 to 7,000, over 7,000 fatalities towards the end of the centuries for Southern Europe. So this is really a massive increase. All other natural hazards, climate-related natural hazards, will not have the same effect. So heat waves will be a very, very serious danger in the future for European inhabitants. The only positive thing here is, as you can see, the cold waves will cause less and less human losses, but all other fatalities will increase, but not as much as for heat waves. So if you have are interested in this article, I can also send it to you by email, or you can Google it. So let's come back to the year 2015, and I hope now you can see the nice satellite images I took from the EUMeTrain page. They have a very long archive of a daily satellite images, and you see here a high pressure area over Central Europe, and it's dating from the 11th August, and 11th August is somewhere here. I changed the pen to have a smaller one, sorry. So 11 August is somewhere here in the middle, and we are here in this diagram. And this diagram just shows you the average daily temperatures during the year 2015, and different colors. The legend is on the right-hand side. Sorry, it's in German, but I had no time to translate it. Anyway, it just shows you, you can imagine, quite easy to understand. Orange is warm, but usually normally warm for the season. Red is too warm from the season, and dark red is a new maximum, temperature maximum. So this is always the daily average temperature from 7 p.m. to 7 p.m. And you see that in the year 2015, which was quite a hot year, and 2 years ago I was also talking about the heat waves, and there's a nice Wikipedia article. I have put the link here. Unfortunately, it's only in German. But you see that there were 4 to 5 heat waves here, another heat wave, and the last one in September. So if you count this September heat wave also as a summerly heat wave, then it's 5, but otherwise we have 4 major heat waves. So if we go to another year, for example, last year, 2016, you will see that it was quite a warm summer, but no distinct heat waves. So we had a lot of warm periods, also in the winter year, but it's not extremely warm. So we were not as much sweating in 2016 than in 2015. And sorry, I forgot to mention that this line, the black line, is the Bezugszeitraum. It means the average climate temperature during the period 1981 to 2010. So this is the reference to which the temperatures are shown here in red or blue columns. So now a question to you. Do you remember any hot year in the past, maybe from your childhood? Maybe you can write it here somewhere in the blue box here. Is there a year you remember which was very hot in the past? Maybe 44, 2003, yes, 2010. I selected the station of Vienna, which is not representative, of course, for whole Europe. And especially the year 2003 has been very hot in the western part of Europe and not so much in the eastern part. Yeah, thank you very much. I selected one of these years, the year 2003. Here you see the climate diagram with the heat waves of 2003. They are not very high, not very long each period. Maybe here, yes, this is quite a long period. But what is astonishing, it started very early. So it started already in mid of April, end of April, to have only temperatures about average, and this lasted the whole summer through until the end of summer. So this was really a hot year. Vienna was not so affected. I have also put here a satellite image of the year 2003. It's from Meteosat 7, I suppose. It's not MSG because it's not in color here. But there's also a Wikipedia article. This time it's in several languages, also in English. You can have a look at it if you're interested in this summerly heat period. So 83 was also a very very hot summer weather. Here is an image, I don't know, from Meteosat 2 or 3. It's also from the EUMeTrain page. And you see in 83, yes, we have heat waves here. There are quite a lot of them, but there are also colder periods here in between. Yeah. So it was, at that time, it was felt as a very hot year. I selected a few others ones. 57, I don't know if someone mentioned this. I had some look in the chronicle, and so I picked out this years. So 1957 was a very hot year, a heat wave until mid of July, here with a maximum even. The North Sea, this is astonishing. North Sea had temperatures of 22 degrees, which does not happen very often. But the rest of the year, you see, we had cold periods in August. and in July even. But the beginning of the summer was really, really hot at the time. Still, there was a mix of hot periods and colder periods. And for example, here in the year 1930, this was a really cold summer, so no heat waves. July and August were quite cold, and the July was even colder than June. And Munich had in that year, in July, no temperatures about 12 degrees. So it was really a cold summer. I go back. I have another one, two other ones. 1921, for example. Here we have a heat wave. But the summer started quite cold here. So we have also here a mixture of cold and warm period. And you have to take into account that this black line is still the reference 1981 to 2010. So compared to the last climate period, you see that the summers were hot. They were felt as hot summers. But in fact, compared to our summers, then they were not so hot. So we had a heat wave over Europe, and the people in the papers complained about low water in rivers, so that the boats could not go through the rivers anymore. The last one is 1911. This was said to be a very hot summer also, and you see that if you look at the climate diagram, especially if it's compared to 1981 to 2010, the red heat waves are not so big, and Berlin had a temperature maximum of 34.6, which is quite normal nowadays. Nobody would be astonished if this were some very hot. But at that time in 1911, this was felt as a really hot summer day, the 23 July. So, in my last slide here is the present year, and you can have a look at it, the heat waves, and I don't think I have to comment them further. So thank you very much, and I give back to Yasmin.
Okay, thanks a lot. Great. So half an hour is almost over. So I will quickly go through the outlook for the next days, starting with today, 15 UTC, today in the afternoon, evening. Here we have in the upper line the geopotential at 500 hectopascal, and on the right-hand side the equivalent potential temperature, and in the second line we have precipitation and relative humidity to the right. I will mainly concentrate on geopotential height and equivalent potential temperature, and go now in a couple of time steps until Monday afternoon, evening, so that we can see what's happening. Here we still have this low pressure system over France that is moving towards the east. In the next days, we also have we have here this air mass border that is crossing Austria, Germany, Italy, and then Croatia, and moving towards the east. Right. So, the low pressure system is moving towards the east. It's somehow dissolving and then forming a huge trough that crosses Austria on Saturday in the morning during the day, causing some rain in these areas, and then afterwards some high pressure areas are approaching with very weak gradients. We can also see in the precipitation and here in the precipitation and in the relative humidity that it gets much drier. And finally, the low pressure system is over Greece and moves farther on to Turkey. Basically, probably lots of sunshine expected for the beginning of next week. We should have a look on this low or this little trough that is included in this westerly stream, but basically there will be a lot more stable situation on Monday and probably also on Tuesday. All right, here's one last chart that shows the precipitation probability for more than 1 millimeter. We have Friday, Saturday, Sunday and Monday, and it shows that this precipitation over here on Friday moves farther towards the east, while here on Sunday there is this huge frontal system over the Atlantic Ocean that is approaching Europe then on Monday and maybe causing some more rain during next week. All right, so that was all for me and for Andreas. Thank you very much for your attention, and now there's some things about some organized stuff.